Hi everyone. We're back, and this time we're back for the mental health sub team. After enjoying the talk by Smriti and Sabria, we are now ready for the next sub theme. And as I said already, we will discuss AI for mental health now. And the first speaker presenting here is also a Smriti, but this time a Smriti Singh. She's an undergraduate student studying at Manipal Institute of Technology in India, and she's an upcoming data science intern at United Health Group, Optum, and a recipient of the MIT ACSGRI Award, so also a winner. And she's passionate about using natural language processing and AI to create sustainable solutions for the challenges society faces today. And today she will give a presentation about applying natural language processing, which of course she has a passion for, to improve mental health. So this sounds very interesting, and I look very much forward to it. And after Smriti, David Berimo will take over the stage. David Berimo is a sorry, psychiatry resident and a researcher at McGill University, and chief science officer at iFruit Health. And David will talk about building an AI-powered clinical decision support system in depression. Mental health matters so much, and that's why I can't wait to start with this session because I think it's so interesting and so important. So let me first give the floor to Smriti, but first a reminder, if you have any questions during the presentation, if they are for Smriti, please ask them in the Q&A tab, which is at the top right of your screen. So please ask them there, not in the chat, because then we have a nice overview of all the questions. But the floor is yours, Smriti.
Hi, can you hear me?
Yes.
Okay, it's great to be here. And let me just share my screen for a minute. Uh, Demi did a great job of introducing me. That's who I am. So, can you see my screen?
Yes.
Okay, great. So, let's just right away get started. Um, So today I'm here to talk about hashtag mental health matters, applying NLP to improve mental health care. So over the course of the next 30 minutes, I aspire to answer 5 key questions, which are as shown. Why does mental health matter? What are the current challenges in the mental health landscape? What are the key challenges in using NLP for mental health applications? How has NLP been used for mental health applications recently? And how can we use NLP to improve mental health care in the near future? So let's start off with the first question. Why does mental health matter? So, in the recent past, we've all heard about the importance of mental health, right? We've heard things like mental health is as important as physical health, and there are all sorts of activities around the world going on to sort of break the stigma around mental health issues. And if you've ever wondered why there's a surge in the awareness about mental health, here are some points to consider. In 2008, the Department of Health and Human Services found that individuals with depression are more likely to develop chronic diseases like diabetes and cancer. Similarly, it was recently found that individuals with depression are more prone to obesity and, as a result, heart problems. So, this is an issue known as comorbidity, right? And it's actually a concern in the healthcare space because what it means is that the like
Smriti, also vanity.
hello. Yeah, okay. So it was found that, like, basically comorbidity, like I was talking about, means that when you have one disorder or one disease, you become automatically prone to certain other ones. And unfortunately, it was found by the World Health Organization that countries that do not have mental health care access also tend to have higher suicide rates. So clearly, mental health matters. It probably matters even more than the credit that it is given today. Basically, we are looking to develop a society wherein people can talk about their mental health issues freely without feeling judged. But more importantly, we are also looking to develop a society wherein mental health care is accessible and affordable to everybody around the world. And while this is an important goal, it's not necessarily an easy one. With that being said, let's consider what are the current challenges in the mental health landscape. So, pressing concerns as of today, there is a limited community awareness about mental health. And what this means is that even though there is so much happening around the world to sort of raise awareness about the importance of mental health, there are a lot of people that still don't take the issue seriously. Like, there are a lot of people around the world who still don't believe that mental health is a serious problem, or that people who are facing mental health issues are seriously facing an issue. And in turn, this has given rise to high levels of stigma and discrimination against people who have to live with mental illnesses. So, what happens is that people are not that willing to talk about it because they're afraid of facing emotions like doubt and shame and ridicule, right? So consider it this way: if you saw someone with a broken foot, right, nobody would question, oh, does a broken foot really hurt, or are you just, too weak to take the pain of a broken foot? No one's going to ask you that. But sadly, the situation is not same for issues like maybe depression or anxiety. And what happens is, even the limited people that are willing to talk about these mental health issues might not be able to talk about them openly, which again promotes the limited community awareness. So we're sort of stuck in a cycle, right? But the problem that I want to draw attention to today is limited human resources. Not only is this a comparatively easier problem to solve, but this is where technology can make a difference. Particularly, natural language processing and machine learning can be used to, detect, diagnose, and maybe even treat certain mental health disorders, right? And the beauty about artificially intelligent solutions is that if they're implemented and deployed correctly, they can be accessible to anybody with an internet connection and a smartphone device, right? So accessibility becomes a great advantage for such solutions. And although that sounds amazing, again, it's not as easy as it sounds. So, with that being said, let's take a look at the key challenges in using NLP for mental health applications. So, any artificially intelligent system needs data, right? It needs data to learn from, it needs data to get better, to train. And just the need for this data gives rise to three primary challenges: they are data scarcity, privacy issues, and ethical issues. And when we talk about data scarcity, it's probably due to the limited community awareness that I mentioned earlier, because, data people are more comfortable talking about issues like maybe their favorite movies or maybe even physical healthcare, stuff like that. But despite the tremendous amount of information on the internet, due to the fact that people are not comfortable talking about mental health issues as compared to some other topics, you will find that there is a huge data scarcity when it comes to NLP for mental health care. And let's even forget about that for a moment, right? Let's assume that you do have a source of data, right? Uh, the question is, should you be using it? Is the user who made that data available comfortable with you using it? So consider a hypothetical situation, for example, right, where there is a model that is capable of listening in on therapy sessions. And this model's purpose is to assist professional therapists in detecting and suppressed emotions that the patients might have. How many of you would be comfortable if I told you that your next therapy session was going to be listened in on by an artificially intelligent system? Quite a few of you might be skeptical. I know I would be too. And that's actually quite understandable. But that is the crux of the issue. And another issue, an important issue, is the ethical issues, which means that let's assume that you even found a way to, obtain some data without compromising anybody's privacy. The concept of ethical AI then begs the question, is it still okay to use that data? For example, let's say you've obtained from some data from someone's website or a blog channel. Is it okay to use that data without the consent of the person who originally posted it? And this is an open-ended question that I'm going to sort of leave for you guys to ponder over. But yeah, these are the three main challenges, and the challenge goes on, right? I mean, there are so many more issues. So then I guess the question then becomes, how is NLP being used to improve mental health care at all? Where does the data come from? And the answer to that question is novice researchers, such as myself at least, we rely on social media platforms like Reddit and Twitter. And the reason is because these platforms, while people are signing up as users, make you sign some sort of privacy forms or consent forms, right? Which allows them to share data with developers. And what this means is that, for example, if you take the example of Twitter, suppose you want to gather tweets about depression, right? You would have to submit a Twitter's developer form. And this would entail that somebody at Twitter is going to take a look at why you want that data and what your intentions are with it. And only if you feel comfortable uh, with your intentions and only if Twitter is okay with the form you submitted, will you be granted access. So this is the sort of compromise that we've achieved for now between like data scarcity and privacy issues. So with that being said, let's take a look at what's being done. How has NLP been used for mental health applications recently? And when I talk about recent research innovations, I'm talking about innovations that have happened in the last 2 years or so. So I'm going to be covering 3 topics over the course of the rest of this talk: the generation and evaluation of artificial mental health records, chatbots powered by cognitive behavioral therapy, and a suicide intent detection platform. So let's start with the first one: generation and evaluation of artificial mental health records. So when I talk about artificial health records, they are basically health records that don't belong to anybody real. So, for instance, if I were to walk down into a hospital and pick up a medical file, that file would belong to a very real person who lived somewhere. When we talk about artificial health records, they are records that have a very similar structure and maybe even similar content, but they don't belong to anybody who's like a person. So, how does this help us, right? It definitely helps us solve the data scarcity problem we talked about earlier. And it also helps us solve the privacy problem to a certain extent, because if we're using artificial health records, we are not compromising anybody's privacy, right? So, this is actually a quite common practice in the medical health space. And the question that sort of motivated this research is, would this practice prove useful in the case of mental health? Because artificial medical records have been generated for tasks such as medical image reporting and even the diagnosis of well understood diseases like appendicitis. So, as it turns out, yes, we can. Using artificial data to train models yielded results that are comparable to models that were trained using original data. So, how does this work? Well, if you look at the figure on the right hand side, you will see that there are 2 key parts in extracting and generating artificial data, right? That is the extraction of key phrases and the text generation. So, given a genuine paragraph, the model has to be able to extract key phrases and generate text to be able to produce an artificial paragraph. And there's a really good example of this on the right side. So, for the keyword extraction, the authors of this paper make use of something called the RAKE algorithm. This stands for Rapid Automatic Keyword Extraction. And other keyword extraction algorithms, just to give you context about this, are the TF-IDF and text rank algorithms. So, how does the RAKE algorithm work? It makes use of stop words and phrase delimiters in a piece of text to find where the most important text within a paragraph or within a piece of text might be located, right? And in this case, it's paragraph because keyword extraction happens at a paragraph level. Coming to the artificial text generation, the authors of this paper make use of a neural transformer model with ED architecture. And the decoder is a conditional language model, which is able to generate new words at each time step while taking into account the previously generated words as well as the inputs provided by the encoder. And in simpler terms, what this basically means is that the model is able to learn based on the past input it's been given and the current features that it's getting from the encoder. This sounds pretty cool, right? Let's move on to chatbots powered by cognitive behavioral therapy. So basically, a chatbot is defined as a conversational agent or an intelligent system that is capable of understanding one or more than one human languages. And a chatbot can be of two types. It can be either retrieval based or generative. Retrieval based chatbots are chatbots that work on the principle of graphs and directed flows. What this means is that retrieval based chatbots make use of predefined responses to converse with the user. These are great for task specific applications. On the other hand, generative chatbots make use of open domain learning, which means that they're able to generate combinations of language as opposed to relying on any predefined response structure. And as you might imagine, for mental health care at least, generative chatbots are better because it's very hard to have a set of predefined responses for mental health purposes. You don't know what state of mind the end user might be in. You don't know what you might be expected to say until and unless that moment arrives, right? So it's better to have generative chatbots for mental health care purposes. And the best part about chatbots are that they can make mental health care accessible to everyone, which is one of our original goals, if you remember. So, currently, at least, there are two popular chatbots available for Android and iOS users. They are Visa and Wobot. Visa is an intelligent virtual coach, which means that she relies on your conversations to detect and understand your emotions, and she helps you build mental skills and resilience so that you ultimately feel better. On the other hand, Wobot is also an intelligent system that is powered by cognitive behavioral therapy. But Wobot basically works a little differently in the sense that it uses your conversations to help you understand your moods and understand yourself better. And what Wobot does is it provides you links and videos and blogs in response to your conversations. So, what that means is Wobot is capable of asking you how you're feeling and what's going on in your life, and basically, they'll send you resources to help you feel better. So, you can understand how different they are in a way, right? And if you look at this table here, they there is a list of responses that you can examine between Visa and Wobot. So, for example, if you tell Visa that I'm feeling depressed, Visa will tell you that can be hard and ask you about your coping mechanisms. On the other hand, Wobot will ask you what situation that you're in that caused you to feel depressed, right? And if you tell Visa you feel lonely, they'll ask you if you have any negative thoughts. On the other hand, Wobot will tend to be a little more empathetic and say, like, I'm sorry about that. I imagine this is making you feel isolated, that kind of stuff. So this is amazing, right? I mean, the implications of these type of projects are endless. And I think that it's really amazing that we are at a point where we can solve such issues using technology. But my personal favorite is a suicide intent detection platform that can detect suicide intent among the depressed population. Uh, so this is a project that was done at the University of British Columbia, where they developed a multi-technology platform that is not only capable of detecting suicidal intent, but also raising intervention mechanisms. So how it works is basically shown in this diagram below on the right side towards the bottom, right? Uh, there's a conversational agent developed using Google Dialogflow, right? And that conversational agent basically interacts with the end user in phase one, which is something called the intent recognition project. So when the conversational agent communicates with the end user, it tries to determine whether they are happy, neutral, depressive, or suicidal. And this is done using a combination of machine learning algorithms. One is a support vector classifier developed by the researchers by training across multiple Kaggle data sets, and the other is the Google Dialogflow's machine learning model. So once this model is able to detect suicidal intents, it uses Google Home Mini to trigger Twilio, which is basically an application that then raises SMSs and calls dedicated to a suicide prevention helpline. So, how does this work? Well, to filter out the false positives, there is a certain classification threshold. Now, what this means is that only when the model is very sure about the user having suicidal intent, does the API to send messages and calls get triggered. And this is useful, right? Because we don't want every single user who seems to be even slightly suicidal to be contacted by this helpline, because then what you're doing is you're increasing load on the suicide helpline. You want to be a little bit sure that the person or the end user in this case is in fact having suicidal thoughts, right? So this is the beauty of this project, right? Imagine if we can actually automate this process at scale. That would save so many lives, right? So I think that's really beautiful again. So all of this might have you thinking, what can we do to help? How can we use NLP to improve mental health care in the future? And the truth is, there's a lot you can do, right? Because the intersection of these fields is a relatively new concept. Both fields have existed independently for a long time, but now that they are at an intersection, there's a lot that can be done. And the ideas that I'm about to provide you are really just the tip of the iceberg. So, there are a few things that I could think of, right? Classification algorithms combined with machine learning, deep learning, and natural language processing can be used to detect mental health disorders. And while this has already been done for like well-known disorders such as depression and anxiety, there's a plethora of mental health disorders that are yet to be made automatically detectable. The second thing that we can do is we can combine natural language processing and machine learning with statistical modeling techniques such as topic modeling to determine causes of certain mental health disorders based on demographical categories like gender, location, or age group. Right? And let me give you an example of this since this is a relatively new concept. So, when you consider something like, let us say, anxiety, right? Let's say that we want to find out that what stresses out people and what actually causes them anxiety. What we can do is we can refer to either Twitter or Reddit or a similar social media platform and see if we are able to categorize that data via some demographic attribute. And why is this important? It's because you're looking at the root cause of the problem. Instead of trying to detect anxiety, you're trying to go a step deeper and say, well, what's causing the anxiety? So, this is also a really potent methodology. Another thing is, of course, the development of chatbots, as we saw just before, that chatbots are being used not only to detect mental health disorders, but also they are a part of mechanisms that can prevent suicidal intent and stuff like that. So, obviously, the potential here is also endless. And yeah, that's it from my side. Thank you for being here. I hope this talk proved useful to you. If you have any ideas or any questions, feel free to reach out at the email below. That's it. Thank you for being here.
Okay, thank you very much. It was so interesting. I think it's such a great way of combating this mental health issue. We actually got quite some questions for you,
Yeah,
so that's nice. Let me just start off with the first one. It's
yeah.
from Bram Bolbena, who's part of our team. Is the scarcity of the data only created by a lack of discussions about mental health, or are there also a lot of constraints on the quality?
Sorry, could you repeat that one more time?
Yes. Is the scarcity of the data only created by a lack of discussions about mental health, or are there also a lot of constraints on the quality?
Yeah, there are definitely a lot of constraints on the quality. That's a really good point. But that's not really something that we can help to the extent that we can decrease stigma. Like decreasing the stigma is in our hands, right? And once people are feel open to talking about these issues, like there's a lot of data available for sentiment analysis or for political discussions, right? And while the accuracy of that is also questionable, at least we have that data, right? So the point of removing stigma is to make sure that at least we have the data, and then the constraints, maybe that's a problem for a later stage, right? Or at least a problem that is solvable at a later stage. Yeah.
Okay, thank you for your answer. If in the meantime, like you feel like your question hasn't been answered as you would want to, just re-ask it, reformulate it, and everybody is invited to ask questions in the Q&A tab, which is on the right part of your screen. Let's move on to the next one. So first, thanks a lot for the lecture. I would really like to. I would really appreciate it if you could throw light upon the accuracy of the suicide prediction model you talked about.
Yeah, sure. Like I said, right? There was, I think, a confidence threshold of 76% set, if I'm not mistaken. But, anyways, all the material that I've gathered, the PPT had links for the original research paper. So, if anything intrigued you in that, please feel free to go check out the papers. They're really cool papers. Should I post the links here, maybe, Demi, for the people to
That
access it?
actually would be great if people want to access it. If you
Yeah,
send the
sure.
links,
Let me
you
just
can
do
just
that.
put them in chat.
Yeah. Uh, yeah, 1 second. So this is the link for the suicidal platform detection. I'm submitting it here. Did you get it? I've posted it.
Yeah.
Yeah. So let me just do it for the other two papers as well, so that in case anybody is interested, they can access it later. Um,
I think we can move on to the next question, and then people can look at the links afterwards.
yeah, sure.
So, because I've quite some questions, is the program that you mentioned adapted to the age? For example, does it adjust the communication to the age of the subject with suicidal thoughts?
No, as of now, at least the project that they have implemented, I think they make an assumption that all users are above 18 years of age. It doesn't say anything about categorizing for age groups. So maybe that's something someone could look into, right? That would be great, especially if we could look at the young adult spectrum of things. I feel that would be amazing.
Okay. Um, and the next one, in the case of the suicide prevention system, who do we want the system to be as certain as possible? Some false positive wouldn't really hurt, right? But false negatives could potentially be very harmful.
That's a good question. But again, like I said, right, the confidence threshold has not been set very high. What we also don't want is for use the suicide helpline to be bombed by, like, let's just say, people get frustrated and tend to say, I will kill myself. And not in all times do they mean it, right? And it's kind of a trade off here. I mean, do you want your system to be able to catch everybody who's even slightly at risk, or do you want people only in dire need to be helped? So, at least in this case, the confidence threshold was not set that high. You certainly want to filter out a few false positives, if not all of them, right? Which I think was the goal of that confidence threshold in the first place. I hope that answers the question.
Ask the rest of your question if you have anything else.
Yeah.
So another question that was in the chat that I've put it in the Q&A is how is feature selection done for mental health status in terms of natural language processing?
Well, that would depend on the task at hand, right? But a good idea is to look at, I don't know, I guess if you're developing a classification model, then you definitely want to look at features like maybe age and suitable demographics if you have them apart from the text, because that could really help you make your system better suited to certain age groups. But it really depends on the task at hand. There are multiple things that can be done, and feature selection is a extremely task specific process, right? There's no one rule that fits all, sort of thing.
Okay. Then I have a final one, which is quite a long one, so bear with me.
Mhm.
Also, root cause of anxiety or any other mental health disorder varied for all people. A student may experience anxiety due to exams, while another student might experience it due to relationship issues. Could you please throw light upon how statistical modeling can help identifying the root cause that may be different even in the same age group slash demographics?
Wow, this is a really good question. I think the answer to that is you should be careful about how you frame your data, if that makes sense. I mean, definitely once you have classified the data by age group or any other demographic, algorithms like topic modeling, if implemented correctly, will probably put topics related to relationships and topics related to exams in different topic IDs anyway. So I think it's about how you leverage the data that you're able to collect, because an important part of modeling, or the part before modeling, is very important, right? The way you leverage your data can make all the difference to the model at hand, if that helps.
Okay. Yeah, thanks everyone for the amazing questions. I really appreciate it. If you still have one, now's your time to ask. And of course, otherwise you can always like contact us as FruitPunch or Smriti yourself. Oh, there's one question. Could voice analyzing help improve the chatbot by recognizing emotions in the voice instead of a black and white text?
For sure, yes. But the problem with that, like I spoke about in my talk, is privacy issues, right? Like, not a lot of people are comfortable with being heard in on by artificially intelligent systems. But if you can work around that issue, then definitely, yes, there is a huge potential for emotions to be recognized simply by listening to voice.
Okay.
Mm-hmm.
I don't see any questions coming up anymore. I see a lot of thank yous, and I want to thank you as well. I really appreciate it, and as I said, I also really like this subject, and I think it's really great to see people working on it, especially in this manner. So thank you for coming. And then I would like to switch to David, who I see is already here, but just has to turn on his camera.
Okay. Thank you so much, everybody.
Thank
Have a
you.
nice day. Take care. Bye
You
bye.
too.